Hey guys, in this video, I'm going to show you how to perform batch and stream data processing using Kinesis Data Analytics. I'll cover the topic in two parts. First, the stream processing, and then batch processing using the same code base in a later video. Here you can see a diagram of a real-time stream processing architecture where events can be generated from various data sources such as microservices, IoT devices, or other AWS services. These events are sent to a Kinesis data stream, which is a serverless service that handles all the scaling, provisioning, and management of the streaming infrastructure for you. You only pay for the amount of data you stream and the processing resources you use. Next is the Kinesis Analytics application that processes the events from the data stream and writes the results to an S3 bucket. Kinesis Analytics is a fully managed service that allows you to process and analyze streaming data in real time using SQL queries or Apache Flink applications. Today, I'm going to show you how to build a Kinesis Analytics application in Java using Apache Flink. Broadly, here are the steps involved in building this architecture. First, we create the S3 buckets to store our results and the Kinesis application jar file. Next, I'll show you how to create a Kinesis data stream. We will use a handy tool from AWS called Kinesis Data Stream Generator, also known as KDG, to create mock events and send them to our Kinesis data stream consistently. We also need to create an IAM role for our Kinesis Analytics application so that it can read events from the data stream and write to the S3 bucket. I'll then walk you through the building of the Kinesis Analytics application in Java. I do have the code up on GitHub for your reference. The link is in the description. Finally, we will deploy and test the Kinesis Analytics application. So let's get started. To create the S3 bucket that will store our results, go to your AWS console and search for S3. If you have previously visited this service, it'll show up in the recently visited select section like it does for me. Click Create Bucket and give it a unique name. Now, S3 bucket names are unique across accounts. So if I create a bucket named Test Results, you won't be able to create one with that name. A good way to ensure uniqueness is to prefix your bucket names with a account number or a random string. I also recommend a quick read of the bucket naming rules listed here. For the purpose of this video, I'm going to use a random prefix A1, B2, C3 and create a bucket with that name. Leave all the default selections in place and hit Create Bucket. Now let's create a new folder called raw events where we will store all the mock events generated by KDG, the Kinesis data generator. We will need one more S3 bucket, which we will use to store the Kinesis application build jar. Let's create that now. So A1, B2, C3, Kinesis application, all the default values, and create bucket. Now that the buckets are created, let's take a look at how to create a Kinesis data stream. Search for Kinesis in the global search bar. And open it in a new tab. Click Create Data Stream. Ensure you have the right region selected. For my video, I'm going to use US East 1 since that's the closest region to where I am. We're going to create a new data stream with the name A1, B2, C3 event stream. Under the data stream capacity, I'm going to select provisioned since I won't need more than a single shard for my test. You can choose on demand if you want your stream to scale with the demand. Finally, click create data stream. The status should get updated to active within a minute or so. And there you go. Let's start sending some test events to the stream now. There's an excellent blog on how to use Kinesis Data Generator from AWS that I'll link in the description below. I recommend following the steps here. Getting started with KDG requires only 3 short steps. Create an Amazon Cognito user in your AWS account, use the user's credentials to log into KDG, and create a record template for your data. Let's click on the KDG help page to help us create our Cognito user. If you're logged into your AWS console in a different tab, then click on create a Cognito user with CloudFormation button. This will open a new tab in your browser to create a new CloudFormation stack using a template that AWS provides. Click next. I'm going to update the name since I already have a stack with the same name provided. Give a username and password that you're going to remember. Click next. Leave all the default settings in place. Hit next. Validate all your selections and hit I acknowledge and submit. Wait for the stack creation to complete. This may take a couple of minutes. After the CloudFormation stack has been successfully created, you will need to use a special URL to access the KDG. The CloudFormation creates this URL as part of the stack generation, and you can find it in the output section of the CloudFormation stack. Click on the link and sign in using the credentials created before. Select the region where you created your Kinesis data stream, and you should see the stream name auto-populate in the stream delivery dropdown. You can configure the records per second to be either constant or periodic. For this test, I'm going to leave it as a constant and 10 records per second. I've created a new template for this test to send events of 3 types. KDG uses Faker.js library to generate data, and this template allows us to configure what kind of data is generated. You can see the sample events that will be generated by clicking on the test template button. You can copy the JSON, and I use JSON Editor Online to format and view the formatted JSON. Once everything looks good, hit send data, and I'm just going to send about 30 records and stop. Let's now switch to the Kinesis Data Stream tab and go to the Data Viewer tab. Choose the shard and select Trim Horizon, and then hit Get Records. You can see all the events that were generated by KDG show up. Now that we have our data stream and events flowing into it, let's focus on building the Kinesis Analytics application. Click on Analytics Applications and Create Streaming Application. Choose 1.15 as the Apache Flink version. You may choose a newer version if it is available, but for this project, I've created my Flink application with this version. Give the application a name. A1 B2 C3 dash event analyzer. You may enter any description that you choose. I'm just going to copy paste my description here. Choose create from IAM roles so that a new IAM role is created for this service, and select development to minimize costs, and then hit create streaming application. Oops, there you go. Once the application is created, the status should say ready. This means your application has been created but isn't running yet because, well, there's nothing to run yet. Click on the IAM role and it should open up a new tab where we can update the policy for this role. Click on add permissions, create inline policy, and switch to the JSON view. Replace the policy JSON that you see here with the following JSON. This will give this IAM role full access to our results bucket and the Kinesis application bucket. It'll also give it'll also give the role access to the Kinesis data stream so that it can read events from this event stream. Click next, give it a policy name. We are going to do A1, B2, C3, service. Actually, service, we'll see, and hit create policy. The IAM role now has access to read from the data stream and write to the S3 buckets. I'm going to switch to IntelliJ and walk you through the building of the Kinesis Analytics application in Java using Flink. Create a new project in IntelliJ, give it a name, oops, and stream assessor. You can choose the location where you want to save it, create a Git repository, set the language as Java, build system Maven, and JDK version as 11. Now I already have this project created, so I'm going to hit cancel and simply switch to that view. So here's my project. As a first step, you're going to copy all the dependencies defined in the pom.xml from the GitHub repository and paste it here. Next, we're going to create a new package called processor and add a single class underneath it called main. You can do a Maven install to ensure all your dependencies are downloaded and the build succeeds. Let's give that a minute. Great. We're now going to define a few constants that we will need. I'm going to paste these here. You can copy it from the GitHub repository. Let's import the dependencies. That looks good. Next, we're going to define a method that gets a map of the config properties that we would pass to the application. Let's import the classes here. Consumer config properties is the group ID that we will specify when adding the runtime properties for the Kinesis application. Next, we define a method to initialize the parameter tool using the config properties that we have pulled. We need to ensure both the path to the S3 bucket and the Kinesis data stream name have been specified in the runtime properties. The getRecordInterval property defines the frequency with which the application will poll the data stream to fetch records. For our test, I've left this as every 60 seconds. We need to ensure both the path and the data stream are specified. If not, it should trigger an error. Define a method to create the AWS Kinesis configuration properties that are needed to subscribe to a data stream. Let me copy that over here and import the constants. We then create a method to get the data stream for a given execution environment. This method accepts the stream execution environment and creates a data stream of the Flink Kinesis consumer. To write events to the S3 bucket, we're going to leverage a streaming file sync. So let's define that. The streaming file sync accepts, oh wait, I think this should be fine. Alright. Sorry. This streaming file sync accepts events of a string type and uses a simple string encoder to write those events to the specified S3 sync path. And finally, let's pull it all together in our main method. We aren't doing any aggregation or processing just yet. Let's just test connecting to the data stream and writing events to an S3 bucket. Let's do a Maven clean install. And ensure that the build succeeds. Once the build completes, we are going to go to our S3 bucket where we define the Kinesis application jar files are going to reside. And we can simply drag and drop the jar that was created from our target directory and drop it here to be uploaded. Once the upload completes, you're going to go to the Kinesis data stream and hit configure. We're going to choose the Kinesis application S3 bucket and specify the jar file, which is the path to the S3 object. Change access to application resources, and let's use our IAM role that we had created before. Streaming file sync writes to the S3 bucket only when a checkpoint is triggered and completed, which is why we're going to enable snapshots and customize our checkpoint config. I'm going to choose 10 seconds and the minimum pause between checkpoints is 5 seconds. Configure these values based on your application throughput. Let's leave the parallelism and parallelism per KPU at 1. We only need 1 KPU for our test. I'm going to turn off auto scaling since we don't need it. Logging is recommended, but it does incur costs. So I'm going to turn that off as well. And we're going to add 2 new runtime properties that we had defined when we were building our application. The group IDs are going to be consumer config properties. The key for the data stream is defined as AWS Kinesis stream name with the value set to be the name of the stream that we had created. And we also need the S3 sync path. I'm going to switch to the code real quick to see what was the name of the property that we used, which was, let's go, S3 sync path, there you go. Let's go back here, S3 sync path. Now the value for the sync path is going to be the URI. So I want the events to be written to raw events. So I'm going to do copy S3 URI, come here, paste this, and now that our jar file has also been uploaded successfully, let's hit save changes. It'll take a few seconds for the application to get updated. Once it does, hit the run button, run without snapshot, since the first time we're running it. And it may take a couple of minutes for the application to start running. So let's wait a few minutes. Okay, it took almost 5 minutes for my application to start running. I'm going to hit open Apache Flink dashboard, and we should be able to view the job that's running. Now that the application is running, let's test it. Since we set the stream initial position to be latest, and that you can see right here, it's not going to process the events we had initially triggered. So let's go back to KDG and trigger another 30 odd events. So I'm going to hit send and stop. Let's go to our results folder and hit refresh. Like I said before, the events will be written to the S3 bucket only when a snapshot, a checkpoint actually, is completed. So we may need to wait for a new checkpoint to be triggered and completed before the events show up here. Oh, there you go. Let's open the file and download it. And this thing just opened right here. And as you can see, all our events are showing up in the S3 bucket that we just created. Finally, be sure to turn off the Kinesis application once you're done with your test, since you get charged for each hour it's running depending on the number of KPUs you have running. You can do that by hitting Actions and Stop. And it'll again take a minute or so to stop the application. In the next video, I'll cover how to update this application for batch processing, where we can read from S3 and write to S3 with minimal changes to our code. If you found this video helpful, please be sure to hit the like and subscribe buttons below and drop your feedback in the comment section. Thanks for watching.